Okay, can you hear me? Okay, so today we will do tides on part 2. Part 1 standard port we have already completed. Now we will do secondary ports which have got a standard port, that is part 2. After we complete this, then we go to harmonic constant method. So today we will complete part 2 calculations. That means a secondary port for which there is a standard port. How to find out the height and time of high water, low water, and any time in between. So I'll just show you this. So the name of the port, I'll give you port number. Then you start opening your tide tables. Name of the port is Sultanpur and port number is 434. Some signal problem is there in between, it just cuts off. So just write down Sultanpur 434 and we want for 07. Okay, just write down the question, then we will see how to go about getting the answer. So find the height of tide at Sultanpur, port number 434 at 0720 standard time, local time, and date is 2nd February 1992. So could you locate this in volume 2? It is there in volume 2 and it is not there in part 1. It is there in part 2. It will also be there in part 3. So we have to start from part 1. Is it in part 1? No. Is it in part 2? Yes. So then we have got that port here in part 2, page number 348, volume 2. Okay, just mark that this port is a secondary port for which the standard port is Bhavnagar. Can you see it is between these two horizontal lines? Bhavnagar is written in bold. So that becomes your standard port. Every other port inside will become your secondary port having a standard port. So Sultanpur 434, Bhavnagar 4346. We have got time and height corrections to be applied to get the data for Sultanpur. So just mark in your tide tables with a pencil also, or write it down on one side in case you have got software copy. Page number 348, volume 2. It is similar to volume 1, only thing we'll be using your duration curves. We are not using range curves. So whatever is given in the red box, you just write it on one side. Standard port name number, secondary port name number, and the data. Now what is the first thing we have to do? We have to get the daily data for standard port. Then only we can apply time and height correction. So we will get the data for 2nd February 1992. Bhavnagar, they have said you can go to page 150. So go to page 150, Bhavnagar. So this is at page number 150, volume 2 only. So this will become our standard port. Now you write down the data for 2nd of February for the standard port. Write down 418 high water, 10 meter, 1138 low water, 2.4. 1655 high water 8.3, 2318 low water 2. So just write down this data as data for standard port. Okay, so now we have got data for standard port. We have got time and height corrections for secondary port, and we can start the calculation after writing this data. Anyone who has not understood this part, how to get the data, how to find out the port in the volume. Now we do the calculation. So this is a form which is given in your tide tables. In the beginning of the tide table only, you will have this prediction form. So either you can fill up there or you can fill up on your answer sheet. So first you'll have to write standard port name number, secondary port name number, date. Time zone is very rarely required unless you want to calculate the time in GMT, or duration of rise or fall is the time interval between high water and low water. So how many hours and minutes between high water, low water? 7 hours, 28 minutes. So after you have written the time and height, why we wrote 418, 1138? Because we want for 720 hours. So we can get it between 418 and 1138. Say 418, 1138 are the data which is available on that page. 418, 1138. So 7 o'clock will come between this. No point taking this 1655, 2318 because we don't need those time. So time directly apply the correction. What is the correction? Minus 1 hour for high water. So 418 minus 1 will become 318. So time of high water at Sultanpur will be 318 on 2nd February. See this standard port data from part 1. time difference from part 2 and you get secondary port time. Similarly, low water time for standard port, time difference, and then you get secondary port time of low water. Anyone has got stuck in the calculation?
So which value we will write in the duration rise/fall?
Here, you can write this side because between low water and high water you can write here. Between high water and low water you can write here. Because we starting with 418 high water, then 1138 is low water. So then you can write in this box on the right side. If suppose instead of high water 418 was low water, then you'd have started from here, low water. Then you can write here. So you have to write in that box which is between the two. Either between the first low water, high water, then that first box, or the second column, high water to low water, then in the second box. How did you get duration? Time interval between this high water 318 and time of low water 1006. Difference between the two will give you duration. Do it step by step. Wherever you are getting stuck, you just let me know. We'll get it clarified for you. Seasonal correction I have already explained to you. Standard port minus and inside bracket whatever is written. And seasonal correction you have to pick up from the bottom of that page. 4342 4354 of February minus 0.1. So sometimes you have to go one page ahead, one page before to get the seasonal correction. It may not be on that same page. Interpolation you can do by this graphical method or you can do by a calculator. So see if you're getting this data. Okay, once you've got the data, let me know. The Sultanpur, have you got 318, 6.7, 10, 06, 1.85 falling tide?
Yes, sir.
So no doubt still.
No doubt.
Now this curves have changed. This is known as what? Duration curves. Why we call them duration? Because time interval between high water, low water, 5 hours inner curve, 6 hours middle curve, 7 hours outer curve. So 5 hours, 6 hours, 7 hours. 3 curves, duration curves are there. Rest everything is same. Your low water height to be on this lower line, high water height on the upper line, then join them, and middle part you write high water time, then add 1 hour because it is falling tide, and then get your data. So just start filling up this curve. First mark 1.85, the low water height at Sultanpur. Then you mark high water height 6.7. High water height always on the top of the top horizontal line, and low water height on the lower horizontal line. Scale whichever it's fitting best for you. So we had 6.7. We can use the inner scale. So high accuracy will be there. Suppose we had 8 meters, 9 meters, then you use the top scale, outer scale. So better to use the inner one. With the red line I have shown you, we are using the inner scale. So make this sloping line 1.85 to 6.7. Then in the middle one, you write the time of high water, 318. So where will 720 come? Little to the right of that plus 4 hour. So the blue line 720, you take it vertical. Draw a vertical line at 720, that blue line. It will cut 5 hour curve here, 6 hours here, 7 hours here. So 3 points you'll get on those curves. But our duration is what? 6.8 hours. So 6 hours is here, 7 hours is here. So you can check so many millimeters equal to 1. So 0.8 times that distance in millimeters, you take it above 6. So you can either interpolate with that millimeter scale or you can just visually put down 6 to 7, 80% of that you get this point 6.8. So the dot will come on this vertical line for 720, and from this 6.8 draw horizontal line which will cut the blue line. Wherever it cuts blue line, you come down and you get the answer. So your answer, if you read on the inner scale, slightly to the left of 3.5. So it is 3.45. So are you getting 3.45 approximately?
Yes, sir.
Okay, then take a 5 minutes break and then we'll resume.
Okay, sir.
Excuse me, sir.
Yeah, tell me.
Sir, could you please open that initial calculation page?
No problem. Today there is a lot of problem with that connectivity only. Okay, question is find height of tide at Sultanpur, port number 434 at 7:20. Just let me know when you want me to scroll downward.
Yes, sir. You can scroll downward.
Okay. Then did you get this information?
Sir, one page up, please. Okay, sir. Fine, sir. Got it. Thank you.
Just mark with pencil, no? Just put a circle around these so that you don't take the wrong value in a hurry. Okay. See, when you see this diagram, no, this is a common diagram for the ports of volume 2 and 3. Not for volume 1 has got those range curves. Notice on the right hand side, top spring and nape range is given. But here these are your duration curves. Okay, duration means 5-hour interval between high water, low water, 6 hours, 7 hours. So in this diagram, you start off by marking horizontal line bottom, your low water height. So what is low water height? 1.85. What is high water height? 6.7. Scale you can take inner one or outer one. Inner one is going from 0 to 7. Outer one is going from 0. So if you have got a value more than 7, then take the outer one. Otherwise use inner one. So 6.7 is the maximum we have got. So we can use inner scale 0 to 7. So 6.7 you mark here. 1.8 you mark on the inner scale. Don't make that mistake of scale. Just put a tick mark which scale is in use. Otherwise you will take some different scale here and another scale there, answer will come wrong. So both the scale you should mark correctly. So mark that scale in use. Here also mark it the one in use. Then put down low water height, high water height. Next, write down the time of high water in this box below the middle of the curve. And if you have to go to the right, why you will go to the right? Because from high water we have to go to low water. That means falling tide. So the right side of the curve is always falling tide. Left side of the curve is always rising tide. So we have got first high water at 318, then low water at 1006. So we are on this side of the curve, right side. So start writing down 318 plus 1 hour, 418, 518, 618, 718. We want for 720. So it's very close to 718. Draw this vertical line, which will cut these three duration curves. 5 hours here, 6 hours curve here, 7 hours. This 5, 6, 7 means this cut is for 5-hour duration curve. This point is for 6-hour duration curve. This point is for 7-hour duration curve. Now our duration is how much? That interval between 318 and 1006. High water time, low water time is 6 hours 48 minutes. So 6 hours 48 minutes is about 6.8 hours. So 6 is here, 7 is here. So 6.8 you can interpolate. Where is 6.8? It's coming here somewhere. So take that dot on that blue line. 5 hours you'll take care duration, 6 hours you'll take care, 7 hours. But we want 6.8 hours. So slightly below. If you want, you can measure distance between this dot at 6 and 7 in millimeters, then divide it by your 10 and multiply by whatever you have got, 0.8. So multiply by 0.8. So you will get in millimeters how many millimeters above 6. Or visually only you can see. 6.5 will come here, then 6.5 and 7 midway will be 6.75. Approximately you got 6.8. Then draw the horizontal line. Wherever it cuts sloping line, drop it. You can drop it here or you can take it on top also. Same answer will be there. But remember, measure on that scale in use. So inner scale, tick mark. So inner scale, what is the value? 3.4 and 3.5 between them. So 3.45. And the time, remember, 318 means this middle dot. 418 means this middle dot, which is showing plus 1 hour. 518 means this middle dot, which is showing plus 2 hours. So 518 line will be this one. 618 line will be this one. 718 line will be approximately the blue one. Now, what doubt in this vertical and horizontal and sloping lines?
Sir, I have a doubt, sir. What if the duration goes more than 7 hours? Then how will we interpret?
Okay. Remember I told you for your volume 1 range curves, less than the nape, use the nape. More than the spring, use the spring. Here in volume 2 and 3, less than 5-hour duration, you don't do by this method. You have to go to harmonic constant method. More than 7 hours, you have to go to harmonic constant method. And in between, if you got F4, F6 value that I'll explain later, then also you'll have to do by harmonic constant method. So here our interval is coming less than 7, so we can interpolate. But if the interval was coming more than 7, then we cannot do. We have to go to next method, which is known as harmonic constant method. Even this one, we should not be doing because we have got shallow water correction for Sultanpur. So we are just practicing for a port in volume 2, how to do intermediate time and height.
Okay, sir.
So remember this, less than 5 hour, harmonic constant method. More than 7 hours, harmonic constant method. In between, interpolate, provided your shallow water corrections are not there. That I'll explain to you. So this method is very much similar to your volume 1 method, only volume 1 had 2 curves. Here you got 3 curves. And in volume 1, less than the neap, use the neap, more than the spring, use the spring. Here, less than 5 hours, you cannot do this. More than 7 hours, you cannot follow. No extrapolation. So more than 7 hour duration, you cannot do. Less than 5 hours, you cannot do. In between, you can interpolate, provided that F4, F6 values are not there. That I have to explain. So are you all getting 3.45 approximately within, say, 10-15 centimeters?
Yes, sir.
Okay. Now I'll show you that overview. Part 1 for standard ports, you will get data given. Okay, there'll be no curve like in volume 1. Now we come to part 3. You'll find all of them are listed serially with respect to port number. See, port numbers are increasing 16, 17, 19, 2, and then the name of the port is given. And the name of the port, if it is coming in bold, that means like this capitals, that is a standard port. And remaining are all secondary ports. But whether it is a secondary with a standard, we don't know. Only thing we know is it is a secondary port. So don't think this is a standard port and everything else is secondary for this standard port. No. Part 3 contains all the ports in order of their port numbers. So don't relate Karachi with these points. Jari Creek, it may not be necessary always. So these are the ports which are very close to each other, but this doesn't mean this creek is a secondary port for Karachi. Not necessary. So for that you have to go to part 2. Part 3 cannot tell you that. Now what all is given in this part 3? Mean level, which is known as Z0 in meters. So Karachi has a mean level of 1.56 meters. That is value of Z0. Harmonic constants are always given as M2, S2, K1, O1. So what does that mean, M2, S2, K1, O1? M2 means predominantly moon. S2 means predominantly sun. That number 2 means 2 high water, 2 low water in 24 hours or semi-diurnal tides. And S2 means 2 high water, 2 low water in 24 hours, predominantly your semi-diurnal tides and effect of sun, mainly sun, effect of moon. K1 means again moon, predominantly moon, but only 1 high water, 1 low water in 24 hours. So these are known as diurnal tides. So K1 is related to predominantly moon with diurnal effect. O1 is related to sun with diurnal effect. M2 is related to moon with semi-diurnal effect. S2 is related to sun with semi-diurnal. Semi-diurnal means 2 high water, 2 low water, 24 hours. Diurnal means 1 high water, 1 low water, 24 hours. So all the components are taken. Component of 2 high water, 2 low water, and component of 1 high water, 1 low water. For moon, moon is M2 and K1. And for sun, S2 and O1. S2 means your semi-diurnal and the effect of the sun. O1 is diurnal, effect of the sun mainly. So have you understood this mean level M2, S2, K1, O1? Under M2 you will get 2. Like this will be in degrees, G will be in degrees, capital H will be in meters. So you got 295 degrees, 0.62 meters. Here you got 30 degree, 0.2 meters. So G and H value, we call it a G value and H value. Okay, that M is only unit, meter, and the G, that degree sign is there. So actually it is G value, small g value, and capital H value, which we'll have to use in our calculation. So under M2, G value, H value. Under S2, G value, H value. So you have to find what is the G value, H value under M2, S2, K1, O1. Then comes your shallow water corrections are 1/4 diurnal and 1/6 diurnal. 1/4 diurnal is given by small f4, capital F4. 1/6 diurnal is given as small f6, capital F6. These are basically effect of the land masses and shallow waters in that particular region, how they affect the tide. So this is due to the gravitational effect. This is due to the shallow water and landmass effect. So we will need to take into account in our calculation M2 values, S2 value, K1 value, O1 value, F4, F6 values. So you can see that F4 is showing in degrees and capital F4 is showing in numerals.
So what is the difference between F4 and
F4 is quarter diurnal and F6 is 1/6 diurnal. That means these are the two harmonic waves. These are basically harmonic waves. One wave has got a quarter cycle, other one has got 1/6 of a cycle. So like frequency you have got, similar to frequency, one frequency and the other frequency, how they are moving. So their movement will be given with respect to degrees and value. So I told you shallow water concerns what? One is your depth and the other one is shape of landmass. So particular areas you have got, see, if you see the world, and gravity is almost the same everywhere, hardly any difference in gravity. So M2, S2, K1, O1 are basically gravity. So they should not cause any problem as far as your position on the earth is concerned. Whether you are in the base of the Himalaya or on top of the ocean, it should not matter. You should get almost the same gravity. But the problem is shallow water corrections. That means how the landmass and shallow waters are there around your position. So if you see Hawaiian Islands, you have no land masses around. That means no shallow. And Hawaiian Islands have no, you can say shallow waters around and no landmass both. So F4, F6 values will be very low. So what will happen? Your height of tide is only due to the gravitational effect. And how much you think will be the gravitational effect? How much will be the rise and fall of water? Approximately due to gravity? Approximately. So 1 meter, 2 meter, 5 meter, 7 meter, how many? You can guess any amount, any number you give.
1 meter, sir.
So actual values will be less than half a meter. If you take only gravity into account, it will be less than half a meter. The problem is the shape of the landmass and the shallow water in the region. So see, Gulf of Kutch has got like...
So your voice is not coming.
As in Gulf of Kutch, it will be 10 meters. Now look at Gulf of Khambat between Gujarat and the west coast. That small where your Alang is there and the Dahej is there. Again, you have got a funnel-shaped landmass and...
Sir, your voice is not coming at all.
So we can't hear you, sir.
Okay, so try and understand this. K1, O1, they deal with the gravity part. Gravitational attraction of moon and sun, how they are affecting. And which gravitational attraction? One is your semi-diurnal, where two high water, two low water. And the other one is diurnal, in which there is only one high water, one low water. So both the components are taken into account. Why this is happening? Because of change in declination. I will show you. I'll draw a diagram and show you. Because of change of declination, sometimes you get two high water, two low water. Sometimes you get one high water, one low water. So declination keeps changing. So accordingly, they have to take both into account, diurnal and semi-diurnal. And shallow water, they have to take the effect of the shallows and your landmass shape. So each and every port will have some values here. If there are no values here, that means negligible. We can take them as 0. So any doubt as far as port number is concerned, the place is concerned, Z0 value, mean level, if there are no tides.
So can you explain mean level again? What is mean?
Mean level is suppose there is no rise and fall of water. Okay. So what will happen to the level? So you will have it 1.4 meters above your chart datum. That is your lowest astronomical tide here in Gwadar. So mean level means between your high water, low water, what is the mean value? Suppose the water was not rising up or going down. What will be the level of water? So that is mean level, because it can go below that mean or go above the mean, like a cosine wave and a sine wave. It can go above and down a horizontal line. That horizontal line about which that sine wave, cosine wave is there, that is your mean line. So mean level is clear?
Yes, sir.
So assuming there is negligible rise and fall of water, what you are getting is mean level.
Excuse me, sir, you are telling about Gulf of Kutch and Gulf of Khambat. Could you explain it once again, sir?
Yeah, okay. I'll just draw it and show you. Approximately, I am drawing this diagram. This may not be perfect, but I think it will solve our purpose. This is your Gujarat. Now here what is happening? Tide. What is tide? Tide is movement of water horizontally. Where is it trying to go? It is trying to move towards the nearest point of the, you can say, earth to a body. So if you have earth here,
Sir, we
and
can
you,
still see this PDF only.
Acha, you're not seeing this. Okay, I think I have not shared it with you. Can you see now?
Yes, sir.
So what I'm showing you here is your Gujarat and your maybe Mumbai is somewhere here. So this area is Gulf of Khambat and this area is Gulf of Kutch. So when the water is flowing, this landmass is trying to act like a funnel. So it's going to rise because of this shape of landmass. And when it comes to shallow waters, it further rises. So when you are standing on a beach, suppose this is a beach, this is land, you see a wave very far away in the ocean, hardly visible. But when it comes close to the beach, you will see it breaking also. So when you stand on a beach, you will see distant ocean is absolutely calm. But there are waves breaking on that coast. Why is it happening? Because that wave which is traveling in the deep water is coming into shallow water, it slows down. Whenever something slows down means pile up will occur. So it's piling up which causes the height to increase. So same way when water is rushing around due to gravitational attraction, this water will start piling up because of the shape of the landmass. So one is how landmass is there. Next is as soon as it comes to shallow waters, again it will start rising because shallow water also causes it to rise. Shape of landmass also causes it to rise. So what is the height of tide here? Maybe 10 meters. Now look at Gulf of Khambat. That Alang and Dahej is there. Again the shape of landmass is there which is acting like a funnel. Again those shallow waters are there all around in that Gulf of Khambat. So here also tide could be 8 meters, 9 meters. Come to Mumbai. Shallow is there, yes. But the shape of the landmass is just straight. There is nothing which will cause rise of water like a funneling effect. So what will happen here? The tide will be only 3 meters, 3.5 meters. So this F4, F6 values is trying to give you what is that number which has to be used in our calculation to take into account the rise due to shape of landmass and the shallow waters in that region. So Mumbai shape of landmass is not affecting as much as shallow waters. And in Gulf of Khambat, it is little open, but that shape of landmass is affecting along with shallow. Gulf of Kutch, shape of landmass and shallow both are affecting. That means the tide will be very high. It is something like you throw a bucket of water in a room. On the floor, the water will not rise more than 1 inch. But when that water touches the wall, now it start rising. It may go up by 1 feet also.
Sir, your voice is again stopped.
So just remember, gravitational attraction cannot make the tide rise by even half a meter. But the shape of landmass and the shallow waters can make it rise by more than 10 meters. Okay, is that clear?
Yes, sir.
So in our harmonic constant method, we have to take into account those F4, F6 values I was showing you. So this M2, S2 is what? Gravitational attraction, moon mainly, sun mainly, 2 high water, 2 low water. K1, O1 is what? Moon mainly, sun mainly, but 1 high water, 1 low water. So this is all, everything has got to do with the gravitational attraction. That means your distance of the body, declination of the body, that will be taken into account. But when we come to shallow water corrections, then we have to take these values which are 1/4 cycle and 1/6 diurnal cycle. And these values will take into account the rise of your tide due to shape and shallow waters. Shape of the landmass, shallow water. That will be taken care of by here. And finally, we have to take into account those seasonal corrections. So seasonal corrections are also taken into account in harmonic constant. I just explained to you fast for diurnal and semi-diurnal. So this is the Earth and so this is the equator, so North Pole. And suppose we take position of moon here, M1, and position of moon here, M2. So what will happen to the water? In position M1, the water is going to rise like this. This is for M1. And position M2, it is going to be like this. But the Earth is spinning like this. west to east. Spin of the earth is like this. So take any position here. If I take M1, you will see high water, low water, too high water, too low water. Take any point. You can take equator. You have seen high water. Then after 12 hours, again there is this high water. So that is why M1, if zero declination of the moon. But when you got moon at a higher declination, say 25, 30 degrees, then what will happen? You take a position here, no problem, near the equator. You don't have any. See the purple one, you are only getting one high water here and a low water here. So one high water, one low water, because the declination has changed. See, I'll draw again. Look at this is your equator, and this is the shape of the water which has changed due to the moon, and you rotate the around a latitude. So you got low water and you got high water. So what does that mean? In 24 hours, you will experience only one low water, one high water. The tide has become diurnal here, and tide has become in the blue one semi-diurnal. So as the declination keeps changing up and down, the diurnal component and the semi-diurnal components are taken into account. So we call it as M2 S2 semi-diurnal. That means the declination zero component, zero declination. And the other one we call it as K1O1. That means maximum declination, moon and the sun. Moon has got 70% pulling power, gravity, because so close. Sun has got 29%. 1% remaining bodies. So main pull of the gravity is from the moon. So next time we will do in details harmonic constant method. So far any other doubt? Okay then. Thank you.